Okay. There's Songling. There was a common question on this, the documenting with the styles, with the sub-style. How do you get it to start with A? When you do a second list of the sub-style or a third list, and you want to get started, how do you get to start with A? Okay, and so I said at this point it's fine. You can just backspace it out, start with A again each time. But I want to show you how you actually do it, so that when you start every time you start the sub-question style, you actually get A. So, this is here. This is the normal to start with. Okay, and so then I want to, let's see, I want to zoom out a little bit. If you want to open up Word, if you got your laptop, you want to follow along. Okay, so now what I want to do is I want to define the question style, and I think in the question style we had the first line indent out this way. Is that right? And the actual, then the hanging indent was parallel with the normal left margin. Is that right? So this is question number 1. Which will be in question style. Okay, there we go. So there's question number 1. Okay, maybe there's question number 2. Also in question style. Oh, but I didn't define it. Okay, so go back. So what I want to do is I want to define this as my question style, and to do that so that the sub-style is based on the question style. When you start a new style, it'll be based on whatever style you were before. So for instance, normal. So this style is based on the normal style. So I want to customize this. So I want to go to Format, Bullets, and Numbering. Okay, and I want to customize. So here's the key. It's got me in this paragraph. So the key is that I want to always, so it starts at 1. So if I base the sub-question style on this, then it will always start from A, because it's based on this style that starts from 1 every time, which is only once. Okay? Okay, so I'm going to call this question style. Alright, so now I'm continuing in question style, so this also in question style. And another. Okay, but now under 3 I've got my subheading. Okay, I don't want 4. Now I want to define the new sub-style under 3. So here's what I'm going to do. Right now I'm going to change. So you see we're working from the question style to define this new style. So it's going to be based on it. And the question style always starts at 1, so the sub-style should always start at A. Okay, so I'm going to change the paragraph, so I want this one to be something like hanging indent there, and maybe there. Okay, so, wait, try that again. Okay, so A. And this is going to be sub-question. So here's our new style. You like my style? Right. So there it is. So now I'm in sub-question, and it's giving me a list A, B. So this is B. and C. Okay, so now I'm done with 3. So all I have to do when I click and get D, I just have to go back here and do question style, and it'll turn that D back into a 4. I'm back in question style now. Okay, so now same thing with 5. If I go now, don't type anything. Just hit return and give you that 5. Change the style to sub question. And it didn't. I know your pain. Doesn't always cooperate the way you think it should. So I'm gonna try that whole thing again there. Okay, this is question style. Another in question style. All right, so if I hit sub question, this should give me an A. Did it give me the right things? It's not quite the same. Why did it change it? It changed, I don't know why it changed the hanging indent. So up here my sub question style is there, and here it moved the hanging indent over. Like I said, I know what you go through here.
Do your styles get saved when you close out of Word and open it back up?
No. So yeah, so it's just for that document. If you're going to open a new document, the style that you created for that document will not get saved unless, what's that? For all new documents, you still have them? Yeah. The pain is almost over. So going back to question works, but if I do sub question,
it doesn't have like main question, sub question, but that one that we did in class, the question, that's
okay, we're gonna quit here, but so anybody have a question about this?
Just put in the
What's that?
So we just type in the basically.
Yeah, it worked for me before class. Now it's not doing it. So for anyone who's interested, I'll keep hammering at it and trying to figure out what it is. But we're close.
As long as it's easy enough to change it back to an A, we're good.
But what's really strange here is I defined sub question, and then when I started it again, it's changing the hanging indent. I don't get that. Anybody have any insights? Anybody have any insights? Okay. Let me know if you're. I'll still try to hammer out your issues and problems with it. But that's the best I can do at the moment. Okay. Let's want to talk about in the syllabus. The first thing in the syllabus is course description. And I want to talk through some of the things that this is pointing out. So the first thing Here it says this course is called Technology and Mathematical Visualization. However, it's really a course for people who want to gain insight into mathematical thinking, learn how to make a quest for insight your way of learning mathematics, and help mathematical learners gain insight into mathematics and learning. Okay, so what percentage of this is about you, and what percentage of this is about your future students?
Who's first?
What's that?
66% is about us, with some being decimals.
Okay, so the first two are about you, right? 2/3 of these are about you. So gain insight into mathematical thinking, learn how to make a quest for insight, your way of learning mathematics. Okay? This is about you. So this course is about you and you learning to keep shifting your orientation of learning towards a conceptual orientation away from procedural or computational orientation. Okay? The third one, help mathematical learners gain insight into mathematics and learning. So, what percentage of this is about your future students? All of it. Okay? 100%. 100%. What you have is what it's gonna determine what your students have. Okay? So the more that you're about an endeavor for understanding and using visualization and technology to make it about understanding, the more your students will also learn in that way as well. Okay, technology can play a vital role in all three quests. First of all, you can create visualizations that provide talking points for your own thinking and for discussions with students. Okay, so we kind of mentioned that last time. So visualizations that you can build a whole discussion around. Okay, you can clarify your own thinking as you design visualizations to convey your thinking. Okay, so what happens is, okay, I know I'm thinking about, I really want to show this to my students. If I can have something, you can imagine that visualization in your head, and you really want to create that for your students. Well, as you create that, especially in a challenging situation, if it's a challenging visualization to create, then you're not going to get it perfect the first time, right? And you're going to learn as you do it. And so every time I create something with Graphing Calculator that's a little bit harder than what I did before, do you think I just type all the code in, all the lines in perfectly and it works? No, I'm using trial and error, and what's happening is it's clarifying my own understanding of it. Okay, and I love that. I love that struggle and that working at it until I get it, and it's just the way I want it. And I'll give you some examples here in a second. Okay, you can provide students opportunities to gain insight into mathematical ideas with visualizations that you share, or with visualizations that you ask the students to create. Okay, so then if you ask your students to create visuals, they go through that same process too. Okay? If you have any comments or anything to add or questions along the way, feel free, just jump in. So in this course, learn the basics of creating mathematical handouts using MS Word and other programs. Learn to use graphic software in investigating mathematics, other programs for creating figures and diagrams, and then all the above to design learning opportunities for students. So, what is the big deal about enhancing your own mathematical insight and understanding? Why is 2/3 of this course about your improvements, your continual shift towards a conceptual orientation? Okay, we said this. Your mathematical understandings are a major determinant of your students' understandings, and your attitudes towards making sense is a major determinant of your students' attitude toward making sense. So what you have, you're passing along, whether directly or indirectly, whether you like it or not. So we have the responsibility. If we have a goal for our students, we have the responsibility to embody that goal ourselves first, right? Okay, so we talked about that. So I just want to give you a couple examples of ways visualizations are used, especially Graphing Calculator. Okay, here's a problem that I posed to my or project that I posed to my Calc 2 students. So this is Clara the calculus cow. She's been tied to a silo with a radius 2 meters by a rope attached at the westernmost spot on the silo. The rope is just long enough for her to reach the easternmost point on the silo. Then later in the project, find the parametric equations for the path the cow can travel around the silo by always keeping the rope completely taut. So that's a statement of kind of the setup of this project and this one part of the problem, finding the parametric equations for this path. So when we give our students something like this, a project or a problem or something to think about, our goal is to give them the highest understanding. So who thinks they have a pretty good understanding of what this is asking? Or is it shaking your head? Not sure. Yes? You think you got it?
I wouldn't be able to write the equation off the top of my head, but I understand that.
Yeah. Can you understand what it's asking is what I'm getting at. Okay, so if we want to increase the probability of our students understanding the project, well, we gotta zoom way out here. See what happened? So if we want the highest probability that our students understand what's going on in the situation, should present it as I did before, A or B? Did the light bulb come on for other people too? Does it make sense now, right? Okay, so my students did not have to come up with this, okay? But you will, okay? So this program can do very sophisticated things, as you see. Okay, so this visualization, it just opens opportunity for a whole discussion that would be a lot more difficult with just the text, obviously, right? So I'm sure there are many of you that your understanding of the problem doubled or tripled just in 5 seconds having the vision, right? Okay, and so then this is an example of how sophisticated the types of things that this software can do. And this is only the tip of the iceberg. Okay, so another example. So that's, using a visualization to clarify a problem in order to generate a discussion. Another thing we can use, so this morning in calculus, Calc 1, I built a whole, let's see, where is it? There it is. This, probably half to 2/3 of the lesson I built around these series of visualizations. And I started with looking at these two bars representing quantities. The length of the bar represents quantities. And I asked them, if I were to extend the red bar to here, these have relative size to one another, and I were to extend the red bar up to here, where do you think the blue bar would end up? Here, here, where would the blue bar end up? If I extend the red bar. What's that? Yeah, so they're in a relative size. The ratio stays the same as their relative size. So I said, okay, if I'm going to take the red bar to, say, here, where's the blue bar going to end up? And I gave him a bunch of choices. And I asked them to explain so they work together with people around them, and I challenged them to explain their reasoning. So what would you guys guess? If I extend the red bar and the relative sizes remain the same, where will the blue bar end up? Those are supposed to be the letters of the alphabet. That's G. What do you think? Between A and B, where else? What do you think?
You're meaning like a percent?
Some people are saying between A and B. Agree with that? Or other people D? So, somewhere. Come on. They need this on an arrow switch. Jason said between A and B. Nailed it. Okay, so let me just tell you that this whole process was about motivating the meaning of a graph. The meaning of a graph. So what I did is, I said, now, imagine that this blue bar is flipped towards vertically, and we put it at the end of the red bar. And then I'm still going to be able to change the value of the red bar, and the blue bar will still change in proportion that we have in that relationship. So I'm going to take this, flip it onto the end of the red bar, and then still be able to change the red bar, and the blue bar will change accordingly. So I said, can you imagine that? What will that be like? Okay, so now if I decrease the red bar, what do you expect to see? I'm going to decrease the red bar. What do you expect to see? What's that? Okay, how decreasing?
Slower.
Okay, so that the relative size remains the same.
This is also
Okay, then I said, what? I said, if I were to now not change the quantities and think about the point right there at the end of the blue bar, what would that point represent? What would that one point, that visual, that one green dot at the top of the blue bar, what would that represent? Jason?
The maximum length of the blue bar at that length of the red bar.
Okay. So what do you mean by maximum? So the length is of course the current quantity of the current quantity 1, and the length of the blue is the corresponding quantity 2.
Can you just do the slope?
What's that?
Can you do the slope?
My question is, what does the green dot represent? Just the one. What does the one point represent? Initial point?
No, if you, are we going to call that an origin, where the left side of the red? If you call it an origin, it's the distance, the red distance and blue distance from the origin.
Red distance and blue distance from the origin. Other people's thoughts. What does the green dot represent? Okay, it goes back to this whole discussion is about these quantities and their relative sizes. Okay, so it's still about the relative size of the blue to the red. So what does the green dot represent? The points. Not the one point.
Represents the length of the blue bar when the red bar is so long.
It represents a package of information. It represents this magnitude of quantity 1, whatever it is, about 1.7. Also, the corresponding quantity 2, represented by the blue bar.
An ordered pair.
Exactly. So it represents an ordered pair. Okay, so now I showed him this. What's that? What does a vapor trail that you see in the sky represent? What does it represent?
A path.
What's that?
A path that the plane took.
Exactly. It's the locations that a plane has passed by, right? So as the plane goes through a set of locations, it leaves a trail and shows us where it was, right? Some planes you don't want to be on. Okay, but that's showing us where it was. So suppose that we put a plane on the top of the blue bar, and then as we vary the quantities, the plane is going to leave a vapor trail and let us know where it's been. So let's start it again from the beginning, and now let's see the vapor trail. So what I'm doing, just building the concept of graph. The concept of graph is everywhere the top of that blue bar has been is a point that's an ordered pair of one quantity and the corresponding value of the other quantity. I did this in class this morning with my Calc 1 students, talking about graphs. Or, building the idea of what is a graph. It's everywhere the plane has been, right? Every location the plane has been representing an ordered pair of corresponding values. And then we went into function notation. So there's the x. We talked about, see the x down there? Showing the x is the value that we choose for the input variable. And then f of x is the corresponding output. So I built a whole lesson around this progression of visualizations, really trying to get them to see what is a graph. What is a graph? It's a collection of points, each point representing a specific ordered pair that from the relationship of the two changing quantities. Okay, so just want to give you an idea of kind of how I use this and what's possible. There's and we'll see a lot of 3D. I showed you some 3-dimensional renderings last time, but it's a really powerful tool. So we want to, those of you, so do we have at least one computer for every 2 people? Graphing calculator on it? So we want to start learning this. Learning how to use graphing calculator. Is there any questions? So I did a lot of talking there. Anybody have any questions about how I use this, what I did?
That's not. And also, a good way to show why f of x equals y, because you're not those points aren't showing on the x-axis, only showing on the y-axis, which is another concept for students to understand that f of x equals y, because this is y up here, which is interesting. And for me, that's a good visualization.
I think I can put it, let's see, where's that? No, I didn't. Right, okay, yeah, so showing that f of x is
follows the y-axis, follows the points on the y-axis, and that's y equals y, that's the output.
So go ahead and open up a blank window. If there's any more comments, questions about what I'm showing you? Okay, so go ahead and open up a blank window. It should look like this. And one thing, so it is a graphing calculator, but it's also a calculator, and it's a very powerful one. So you can just type in any expression, 1 plus 2. You don't even have to enter, okay? It's just showing you what the current value of the expression is. So I can keep adjusting it, minus 4 divided by pi. As I adjust it and I give it something that's valid, it's going to give me that answer at any given moment. Okay, if you select something and then just hit Shift 9 for parentheses, it'll parentheses around the whole thing. That would allow me to divide by that whole second quantity. So questions?
How did you do the parentheses thing?
So if you can just select whatever you want to put parentheses around and just hit left parenthesis and it should put both of them.
Oh, how do you get the mice?
PI. So yeah, these are all the tricks. Ask me as they come. There's no way I can sit here and explain every single thing, but just keep asking and then also just trial and error yourself. And then at the very last resort, read the manual, right? So just dive in and go for it, okay? Just know that I'm not going to be able to, at some point, tell you everything, but if you have a question, I'll help you answer it. So what I want you to do as an exercise here is I want you to convert in one expression, set up one expression to
It's shift 9, is that what you said? Oh.
yeah, just left parenthesis. Left parenthesis will put the whole thing. So I want you to, did I show you text? If you hit Command T, you can just write text. So I want you to write one expression. So in one line, to convert 90 miles per hour to millimeters per second. So now after to get a new line of code or mathematical language, then you need to do, you always do command return. If you just hit return, it'll just keep you in the same line that you were. So if you keep hitting return in the text, you'll just get more and more space for text. So if you want to start a new math line, at any time, you need to do control return. So this is your task. Work together. So write one expression to find out how many, the rate of millimeters per second is equivalent to 90 miles per hour. Okay?
Oh, is it on there?
Yeah.
Oh, there it is, got it.
We want it in one line so that the answer in the small print is how many millimeters per second is the same as 90.
Sorry, what were you trying to do? We're trying to put, there, just go, with your arrow to the right.
Do you have it downloaded yet? Are you doing it right now?
Yeah.
You get it?
View website.
That doesn't look like it, Jason. There's more to it than that.
Or do you click on Pat Thompson Problems?
So you know you're in the text line. There.
Yeah,
Okay.
I'm thinking.
Okay, sure.
I didn't want to put it in there and then it get all weird.
Yeah, in the name.
How do we,
Yeah.
Forgot how to do the
the text part?
Control T or Control T. Control T.
Yeah, go ahead, Nito.
That makes
Yes, sir.
And it was restaurant, yeah, website.
Are you going through the applications?
Oh, okay.
Yes.
It wasn't able to get it.
I think it was
That's use parentheses so that everything in parentheses is showing one set at a time. Does that make sense? So as you keep using nested parentheses, you're seeing each conversion one at a time. So you can let that one. Because we're talking about defining parameters. It's thinking that you're using parameters. It's thinking that you're doing H times O times U times R. Okay, so it's parameters. It sees as numbers.
So how many miles is I really don't like this format. Where you change it.
Is it mils?
Bring it
We're allowed to look it up.
Well, this is going to have to be this. You'll often get scientific notation, but you're asking, you don't want that or you don't want that. Well, just use multiplication. Just instead of using just.
Well, I typed it in like this. I put it out like that. Like what our history.
Just use parentheses or asterisks in multiplication. So instead of representing it as one number, represent it as a product.
Well, whatever. Never mind. What I was saying is I want it to just be one number. I don't want it to be. I want it to when I do it, just like not change it, just leave it be. And now it's not.
And type it in.
That's what I did.
Type in your number.
That's what I did. And it's
Nothing says it. I have no idea. You should do that. Try again. So.
earlier I did a face
Okay.
I know hours turns into. Right. 1 hour will turn into.
Oh, it's 90 grams already, huh? Yeah. So you think it's 40? You got 40,000. You got 40. That's right.
So just highlight it as opposed to just parentheses around it, right?
What did you highlight?
So
Counting.
I just
Oh, you did? Yeah, parentheses. You just do left parentheses and just put it around. Nope, just the values.
It's giving me that. No, I did that. It has to be a receipt number. Did you have to?
No one else is in trouble.
Well, before class started, did you say these people? I mean, on your end?
There was no list of these names. That doesn't work for anybody. Start over and try again. Okay, so I want to kind of change the task. I want to kind of
That's where I have this.
redefine the task a little bit. What I want you to do is start with one calculation that just one operation that changes this to a different units of rate. Okay, put that in parentheses. Okay, you're gonna do this one step at a time. You're gonna keep having nested parentheses. So each parenthesis represents a new unit of rate that's getting you closer to this unit of rate. Does that make sense? So keep practicing. I'm going to practice nesting your parentheses. So you can say, all right, this is this type of rate, and then this is this type of rate, and then this is this type of rate. Does that make sense? Yeah.
just trying to think. There's 70
Okay.
and then 0.9 miles per hour.
Okay.
So you need
Yeah.
9. And then that's 26 an hour, and 4 hours should
Okay.
be in 1 hour. So
Okay.
that should be
So did you understand how I redefine the problem? So that's fine.
That's
That's okay.
where you kind of lost me. Like with the nested parentheses.
So for instance, if I want to start by doing feet per hour, if I wanted to start with feet per hour, how would I get feet per hour? Yeah, Frank.
Well, you're given it's 90 miles over 1 hour.
Okay.
And then we convert 5,280 feet in 1 mile.
Okay.
And then, what did you ask?
So what do I do to 90 to get feet per hour? Instead of miles per hour, I want feet per hour. So what operation would I do to 90 to get the equivalent feet per hour?
Multiply times 5,280.
This is what Frank said. What do you think?
Well, that'll get you to feet per hour.
Feet per hour. That's all I'm asking. Feet per hour. So we're going to put parentheses around that. Feet per hour. Okay? So from feet per hour, now we're going to millimeters. How about let's do inches per hour?
Times 12.
Okay? So now I'm going to take this whole thing. See where I'm going with this? This is what I want you to practice. 90 is miles per hour. 90 times 5,280 in that first set of parentheses, that's feet per hour. Now what's this?
You need to.
Inches per hour. Okay, keep going like this. Just one thing at a time, and you're always. What can we do next? We want to get closer to millimeters. And we got inches per hour. Yeah? Someone besides Frank.
Sorry, trying to get from.
Someone else besides Frank. You're doing great. You got two perfect. What's that?
Inches to centimeters.
How would you do it?
I think it says 1.54.
And I'm going to multiply or divide? It's actually 2.54. So now what does my expression represent? Centimeters per hour.
How are you getting all the parentheses around it?
Whatever you want to put parentheses around, you highlight it,
Okay.
and then just hit left parenthesis, and it'll do both.
There we go. Thank you.
Okay, what am I at now? So what is this value? 1.4484 times 10 to the 7th. What does it represent? Centimeters per hour. So we want to get closer to millimeters per second. Somebody new? I know Frank's got it. Jason, what's next?
Multiply by 10,
Why?
because that'll take centimeters and millimeters.
So what will the whole expression represent? So that's the number of millimeters
Oh, that's millimeters per hour.
per hour. Somebody new. What's next?
Divide by 60
Why divide by 6? Now what we got?
millimeters per minute.
Okay, so if you highlight and then hit divide, the whole thing will be she wants to divide by 60. What does the value this represent? 2.4 times 10 to the 6th. Millimeters per minute. Is it Melissa?
Yeah.
One more time. What do I do? Multiply by 60? So this whole, I'm going to take this whole quantity and divide by 60. Any questions? So, I want you to work on page 1. This is mortgage payment formula. I can have one of this one. So stay on the first page here. So use what you just learned to crank out some payments. Yeah, I'll be right back. Okay, so it says, everyone got a sheet in front of you? So we're addressing the issue, how to use various tools to calculate a formula. Alright, so your monthly payment on a loan that you'll pay off in equal payments over the life of the loan depends on several parameters. Depends on the bank's interest rate, the initial amount of the loan, number of payments. Here's the formula. So we need to calculate the payments for these 5 scenarios. Okay, so use what you're learning to find these payments. Okay, go. What's happening here is, right, so it thinks you're saying n times I times L times. Yeah, we're yeah, and those, yeah, so if it puts it out of metallic, then that's something built in.
So is there one? I only asked it.
We're getting there. We're getting there today. Yeah. Okay. Yeah. I'm going to show you all that stuff.
Okay, alright.
So you just want to put it in as text. You're just saying, I just want this text in the middle lane.
So they can see like the cancel.
Yeah.
Other than that, they won't.
Yeah.
Yeah.
Mine.
He didn't think out.
Yeah, but
I know.
tangent.
At the moment, they
Never
just happen to be
that way.
with
We never
a
teach
tiny
things.
amount in this. I don't know.
Because it just becomes a procedure advantage. This is no. This is showing in every set of parentheses as meaning.
Oh, I'm sorry.
That's what we did. So the inside set of parentheses, it's different type, different unit of rate, and each one is a different type of unit of rate.
There's a core here that is.
This becomes a procedure, and just they don't understand the real idea of what's why do it.
I mean, that's like literally over here.
Oh, okay.
That's a good conversation. But the question is, can you, in a mathematical line, can you just put text in there?
Or I didn't.
No, I don't.
I don't know, so not the point.
I think I might have helped.
Well, you can, well, you can make the one that, then it's still,
It shouldn't, I don't know if it'll like.
you just want text, you just want to ignore it.
Yeah.
All that's fun stuff. Deal with that.
So I was hoping that.
Oh, some of you are jumping the gun here.
Big,
Who said to put in the formula?
oh,
You're supposed to be doing tedious work there, that's what I want to see. Tedious, awful work, making big expressions of numbers. It is true.
He wants us to
plug in the number.
and put in the answer.
That's what I was gonna do, but just replace it. The variable.
I want you to do that.
But it didn't. For some reason.
I just want you to do that. This is telling you the formula that you're using.
We have to actually.
This is what you're doing to find payments. This is what you're doing to find payments. Just pretend you have a handheld calculator in your hand. Okay.
For ours.
Oh, your IP address?
but it doesn't, it's like, so where the R is, just put in.
We can't, is that not a hundred ideas? That's not my mind.
I don't know.
And then the answer is there.
At least do one or two that way.
I can get it to work the other way.
What, whatever.
The way where you just say the variable value.
So you can tag team. If everyone at the table wants to do a different one, but do it this way. Just like a calculator, numbers. If you want to copy and paste, so you can copy and paste and change the numbers. That's fine. Just this. Just pretend. Forget about all those letters, right? Just put it. Use the formula given. Put in the numbers and get the answer. Just like you had a handheld handling calculator in your hand. Just humor it.
Is that times one? Yes. I was like, what did I do wrong? So it's a really long.
Okay. Issues. Questions.
0.08.
Just change it. Well, I think I didn't change it to. Versus a long decimal. So we're gonna sure that match.
Negative 1, which is one. Negative 180.
So 21 of 960.
Oh, I forgot to pee.
I was just like,
Are you doing number 2?
Yes, sir.
I want to exclude the negative one. Like when I highlight it, it'll always do the parentheses just wrong.
There's some.
Like see how it always includes it?
Try.
I guess other people did the parentheses first, then typed it. I could do it. I just wanted to know.
So what's your expression in there?
It's like 1 minus.
So 2 minus. So 2, say plus 3 minus, and you just want. Yeah, you should be able to do it.
So even when I put in front of the
Yeah.
1,
Oh, you're right.
it'll always like grab that negative. But then that's going to change it. I do the
You're right.
parentheses there. So.
So if you want, you can do plus. Yeah, good question. If there's a minus, why it
I guess I could do a plus.
I guess
highlight
it just-
do
it
parentheses
just
and then change it.
does
Yeah.
it as -3.
Just
That's,
cancel
yeah.
it.
Oh, I forgot that you made it.
Okay, did everyone do at least one strictly by the numbers? Did you all do one strictly by the numbers?
Okay, remember about the team from now on.
Okay. Everyone got to do one with numbers. Okay, flip to page 2. So those who are using formulas typed in graphic calculator, your instinct, your intuition was correct. Okay. So as you see, that would be just doing 5 of those. 5 of those payments would be very tedious, right? Okay. So we want to define parameters. This is the one way that we can make this simpler. So what I want you to do is open up a new math line and just type the letter A. Okay, so what first you'll notice is it's italicized. If it's italicized, that means it's a parameter, meaning graphing calculator wants that to have a value. That value could change, but it wants it to have a value. And so right now, without defining anything else, the value of A is 1. So if you introduce a parameter, but don't don't define it in any way, it's just going to set it equal to 1. All right, so try just try different letters. L, V. Uh-oh. V, what happened?
That's velocity.
Okay, so graphing calculator is reserving V for something, okay? What about X? Hey, remember we talked about this last time. What is X reserved for? Graphing an X value. So this is always referring to the value of X in the plot that it makes. Same with Y and Z. Okay, type the word, type the word the. Okay, so right now that's taking T times H times E. So just type E. How about just type E? E is our E. Okay, that's the value of E. Now type theta. Also reserved the ta. So theta is reserved for, it's reserved for the conventional angle of theta in the xy plane. Okay, so it's the angle swept counterclockwise. Have everyone's attention? It's the angle swept counterclockwise from the x-axis. It's reserved for that, just like x is reserved for the horizontal coordinate. Theta is reserved for the conventional angle theta in trig. Okay, and in polar coordinates. Type in phi, phi. Same thing. It's reserved for the value of phi in cylindrical coordinates. The angle tipped down from the z-axis. So you can use these parameters. So you can say r equals, so let's type these lines in like it says there. R equals 0.0625. Then new line, P equals 260,000. N equals 360. Okay, now if you want a word or a symbol or a sequence of letters to represent a parameter, then what you do is you hit backslash. For me, that's above the return key, so backward slash. And then you can type the letters, so say PMT, and then backslash again. So now you just made that character string a single parameter. So that PMT will always represent now, here on out. That will be our payment. So
backslash the string, then
backslash the string, and then backslash again will turn that string into a single parameter. Okay, so we can set up, like many of you wanted to do now, so we can set up what the formula is for payment. So put that formula in. You can also preempt the parentheses if you notice before you do it. Just hit the left parentheses and it gives you both. So you can put it in before instead of doing it after.
Does it keep scrolling down as you add, you keep hitting enter?
Did you figure it out? As many of you figured out, exponent is just the caret. But if you just do shift 2 or shift 3, that'll just give you square and cube. Any other exponent, you need to do the caret. So if I wanted just to square that, I don't need the caret. I can just do shift 2. See that? But here we want n. Minus n, sorry. Does my formula match what we're given? So the question is, why is it?
The zeros not capitalized from
Oh, you're lowercase.
Hmm.
We don't have R list.
You have
Oh, yeah,
lower,
you have a lowercase
lowercase
r.
r inside the.
So that's why it doesn't know what's going on. Okay, thank you.
I use the lowercase r, so I'll put lowercase r.
There we go. So then in the next line, you don't need, so now it's already, this is defined as a parameter. So from here on out, all you have to do is hit capital PMT. You don't need the backslashes anymore. Just the first time when you define it. So no backslashes, just capital PMT. Boom, there it is. So what you can do now, you can cruise through that table, right? You can just change each, as you change R, P, and N, it's just going to keep showing you. So let's do that. So what's
That didn't work for me.
Do the two that two does.
so let's do, I'll just do the first line. So in the first line, R is 0.055, P is 280,000, N is 360. And so as you change those values, look, notice as you change those parameters, payment will change accordingly. You don't even have to do anything. Get the new payment. Okay, troubleshooting.
Yep. For this one, are they meaning this number?
Okay, I use little r.
Yeah.
Is that what that means?
It does.
Okay, because it just looks.
So it has to be r, big R, I guess.
Yep, it just makes it
As soon as I change my big R, and then I get the PMT on the bottom.
You have a question?
Okay.
So we're on page 2.
Really?
So you guys don't get this table? How about this table? How about this table?
As a backslash.
Oh, no, I believe you. It's the end of this question.
Oh, right. I don't know, that's really weird. I don't know. Oh. R is one of the variables. Lowercase r is on the back.
So this is a nice, can I have your attention? This is a nice reference, as you see up there at the top, above where it says method 1. There's information, lots of it we covered, but it's showing you what all the built-in reserved values are. So when we put in V, so U and V are reserved for parameters for multivariable parametric equations. Remember from our vector functions could have one or more parameters, and so U and V would be if you had 2 input parameters into that vector function. Those would be U and V. Okay, so you can see all the built-in symbols that are already taken by graphic calculator. Okay, method 2. Okay, so method 2 would be utilizing graphing calculator's ability to do functions. Okay, and that's where this becomes, using functions is where this becomes very, very powerful. So I'm just going to start over. So to define a function, you're going to pick your name. So you can pick any name for your function. So f is, as you know, is the most popular. To define a function, then you're going to hit Control 9. So Control left parentheses instead of Shift. And it gives you a set of parentheses. But now, this is not thinking it's not thinking, okay, I'm going to multiply what you put in there by f, right? Just like normal function notation. What is it expecting now? What's that?
Variables.
Okay, variables or arguments for f, 1 or more. So our function is actually of 3, so we can do f of r, p. Okay, maybe you didn't erase all that, and that was a good thing if you didn't.
Oh.
Okay, we can type it in again. So now, what is it expecting here? What is it expecting?
RP and expression.
Right, it's expecting the rule. It's expecting the rule involving RP and N that's going to be, that it will use to generate the output values of F. It's the rule we just did. Do it again.
Okay.
Sorry.
What do you have in the Oh. Can you say RPM equals PMT? Or the F of that equals PMT? Would that work?
I don't think so.
Okay.
Let's think about it.
This is so cool.
Okay. So here we go. So make a new line. So every time, so now, when I write F, what does Dragon Calculator think or expect? So as soon as I put F, it invoked, oh, F was defined as a function. So the next thing it needs is, it's gonna want values of RP and N. So this first example, they say do 260,000. Uh, 0.065. Okay, if you define F with 3 parameters, every time you invoke that function F, it's going to want 3 values. Did you get a 1354 payment?
I actually put no.
We should make this bigger. There we get
So the answers are in there for this table. Practice using that function. Make sure you get the same value. Yes, ma'am.
No, you switched up the rate payment. So rate value is where the payment is.
So you're telling me you're going to give it an expression of take that expression. Just grab this, just highlight that whole thing out like this. Paste it. Yeah, now try putting in some. Any trouble here?
It doesn't work for you.
Well, it never showed me. It's like when you submit this, it says it has 100% already on it. It might be. Okay. What I did is we want to have machines on that.
Okay.
Thing so that it's supposed to be maxed out.
No, I'll get you a new.
Okay.
What was N? What is N? What does N represent in this? Don't think so. What was N? So you're.
We put them in wrong.
Yeah, those are wrong. Your rates and your payments are backwards.
Yeah.
What happens here?
I'm like,
You switched your RMP when you put it in the second one. You put your money first instead of the percentage. Right.
I mean, you need to change it up there. Change your P and R around.
Okay, so what's going on here? So this
You
should.
have your P first on the bottom
Okay.
instead of your
Change those around to be easier. Or that.
And what should this be?
26,000.
Okay, what does N represent? Okay, this is for finale here. What does N represent? What is the parameter N?
number of payments.
Number of payments. And so what time period is that? We're making payments. Is it monthly payments? So what if I wanted, okay, what if I let the number of payments be X. What am I signaling to graphing calculator? What's that? I want a graph. And so what is my horizontal axis going to be? It's going to represent what on the horizontal axis? What comes in the third? What's the third argument of F? Number of payments. So it's going to graph
The
number of payments as the independent variable. So if I want y to be if I want to output the payment, then I can say y. So now I'm signaling it to show me the output. Show me as a y value the payment for a number of payments x.
And those are constants. Those two are constants.
Keeping the rate and the principal constant. Right, exactly. So this function that we're going to show is for a fixed principal amount and interest rate. So if you hit enter, hit graph.
Very cool.
Nothing happens. It's too high up there.
What's wrong?
Your window's not set.
Okay, so we got to get the window right. So first of all, what should our x-axis show?
These numbers, like
Only positive.
every
Okay.
only positives. Probably
Positives.
every 20 or 50, maybe over 50.
So we want to shrink the horizontal axis to see more of x. How about that?
That's good.
Shift or control.
Shift or control allows you to zoom in and out on just one axis. Okay? Why can't we still see the graph?
Because your Y value is
What's the output of this? What does the output represent?
the payment you're going to have to give.
Yeah, I'd love to have a $4 payment on my house too, right? Not going to happen. It's not going to happen. Okay. So we need to show more. What's the payment going to be like?
Like 500.
500, 1,000, 2,000, something like that. Oh, look at that.
There we go.
What about this part down here?
Oh.
Relevant?
No.
Because?
Negative.
So what you can do is,
A lot of us have negative money.
okay, listen up, watch, almost done.
It's red.
You can do comma, x, I just want to show this graph for x greater than 0. And then I can grab it, move it down. What is this showing? For, if I only wanted to make
That many payments.
150 payments, so you can click on this, click on the graph. If I just want to make 150 payments, what does the output tell me?
Yeah, paying $2,500 a month.
That my payment will be $2,500 a month if I only want to do 150.
That's amazing.
So then you can change x. As you change x, your number of payments, the more payments you have, obviously, the lower each payment will be, and that's why this is decreasing graph.
There's a point, it looks like might be a point where the number of payments and the amount you're paying is high up.
Well,
Because
that's
you
a-
never get down to 0 at least. So
yeah, it's forever decreasing, but never 0. Yeah, forever decreasing, never 0. Limit is 0.
That means if you wait that long, you're never going to pay it off.
Oh, yeah,
Pay
this year
numbers
is
or something.
Okay, so you have your the critical précis. So as a guideline, that summary in itself is 400 to 500 words. Okay, but if yours is significantly more than that, that's okay. It shouldn't be significantly less. Okay, that's just a general guideline, but there's no set outline. So you read that definition on Wikipedia to kind of guide what you're doing, but then there's also the discussion questions. So you're writing the summary, the critical précis, and then you're also answering those discussion questions. And we'll just go ahead and just print out a hard copy of that to turn in class on next Wednesday. Okay. In addition, there is another graphing calculator assignment, creating a document showing that we're learning, we're progressing using this. So 2 things. That one will be a reply to me. So 2 things for next Wednesday. Watch for an email. I'll post that assignment on Blackboard like the one that you had for today. You'll be replying to me, and then you're going to bring a hard copy of Critical Précis and discussion questions to class. Any questions?
Is all of that posted on Blackboard?
It will be.
That critical assignment?
That's already there.
It's okay. Okay.
That's already there. The only thing I have to post is your new driving calculator assignment. If you want to still work on driving calculator, I can answer questions.
Control this, and I guess, but it's the,
all reading it all. Critical system. If you have to answer 3 questions.
Yes, sir. Hold on 1 second.